Operating a massive industrial facility here in Johor creates daily power demands that are immediate, overwhelming, and entirely inflexible. Keeping the facility running requires a massive baseload to power server racks, continuous assembly lines, and industrial HVAC systems throughout the harshest daylight hours. This relentless demand ties industrial profit margins directly to the national grid. When utility tariffs rise, these margins compress immediately. For local manufacturers, managing energy overhead is a critical requirement for maintaining a competitive cost structure in a volatile energy market. Standard residential or light commercial solar frameworks are insufficient for these loads. Heavy industry requires more than simply scaling up a basic roof array. Traditional net metering schemes often fail factories because they rely on exporting power back to the grid. These models are subject to restricted utility quotas that artificially cap the maximum size of the installation. Achieving commercial energy independence requires the self-consumption, or SCO, framework. The SCO strategy utilizes zero-export architecture, industrial-grade safety hardware, and specific tax mechanics. This framework establishes solar power as a primary, permanent tool for massive overhead reduction. The fundamental operational principle of the SCO framework is its strict zero-export architecture. In this model, the solar generation curve is engineered to rise and trace exactly underneath the factory's daytime consumption curve, never crossing over. Every single kilowatt of solar energy generated on the roof is swallowed instantly by the facility's active load. Because the system is sized to the load, no generated power ever crosses the boundary line to leak back into the national grid. Containing all power within the facility bypasses restrictive utility export quotas that limit traditional solar setups. This allows engineers to scale the physical solar array to match the building's precise, massive load profile, maximizing the displacement of grid power. A zero-export system allows the facility to take complete, unhindered ownership of its generation capacity. Managing the transition from the roof to the factory floor requires specialized hardware. Heavy machinery demands absolute power stability. In a continuous manufacturing environment, minor electrical anomalies can lead to expensive downtime or damage to sensitive server racks. We utilize Huawei smart string inverters as the core of the installation. These units are engineered specifically to process heavy industrial loads with high reliability. High-stress commercial environments are prone to microscopic electrical arcs, which present a significant risk in high-heat industrial settings. These inverters counter that risk with AI-powered arc fault circuit interrupters. If the system detects an electrical arc, the advanced AI immediately triggers a mechanical switch, shutting down the circuit in mere milliseconds. This rapid response cuts the power flow before sparks can ignite, preventing fire risks before they manifest. In high-demand environments, safety requires this level of AI-driven prevention to protect the facility's capital assets. Many heavy facilities operate 24 hours a day, drawing massive loads long after the sun sets. Drawing grid power during these nighttime shifts is expensive, as it often triggers peak demand charges and higher utility rates. To solve this, we integrate industrial-scale battery energy storage systems, or BESS, alongside the inverter racks. During the afternoon, the system diverts excess solar generation into the BESS arrays, rather than letting potential energy go to waste. That stored power is then deployed to run the factory during expensive nighttime shifts, effectively flattening the facility's demand curve. BESS integration time-shifts sunlight, turning afternoon energy into a financial hedge against premium nighttime grid rates. A commercial solar installation functions as a high-yield financial asset. The return on investment for these systems is driven by two primary government tax incentives in Malaysia. The first is the capital allowance, which utilizes standard depreciation deductions to lower corporate tax liabilities. The second is the Green Investment Tax Allowance, or GITA, available through the MITA framework until 2026. Combining these two mechanisms significantly reduces the effective capital expenditure of the project. While standard industrial infrastructure projects often require a decade or more to achieve full capital recovery, these tax strategies compress the solar ROI timeline down to just 3 to 5 years. After that initial payback period, the system provides decades of completely free energy for the facility. The math of accelerated payback makes the decision to delay a commercial solar installation a measurable financial disadvantage. Managing this energy asset effectively requires clean, actionable intelligence. Every SELCO system includes a centralized monitoring dashboard that visualizes real-time generation and savings data. The interface tracks generation metrics automatically, eliminating the need for manual calculations. Facility managers can monitor exact phase load distributions, allowing them to spot and correct inefficiencies across the factory floor immediately. This turns raw electrical data into clear intelligence for managing facility overhead. By merging SELCO architecture, Huawei hardware, and GITA tax strategies, a facility can effectively shield its profit margins from utility inflation. We recommend reviewing your current commercial utility tariffs and peak demand penalties. Contact the Amiya Energy engineering team to calculate your facility's exact load profile and return on investment. Partner with Amiya Energy, your local experts in advancing sustainable infrastructure across Malaysia. Commercial energy independence is achieved through the integration of precise engineering and financial optimization.